The journey always starts from the application layer. So let's say this is me. This is Roland. I want to send some things to Uche. In between, I will be connected to a switch. He will be connected to a switch. Maybe we have a router in between or multiple routers, it makes no difference, and so on and so forth. If I am the sender and he is the recipient, the journey will always start from application layer. So before I can push out my data to go through this network, my data has to go through the application layer. Application layer. Then followed by, if we're talking about TCP/IP now, transport layer. Followed by internet layer. Followed by network access layer. But I don't like it this way, but I just need you guys to see it this way because the network of today are built on top of TCP/IP. So how is it supposed to be if we're talking about OSI? So watch out. If we're talking about OSI, the journey will always start from application layer, followed by presentation layer, followed by transport layer, followed by network layer, followed by data link layer, and then of course physical layer. So just like what we have said before, your data is data at the application layer, data is still data at presentation layer, data is still data at session layer. But when data gets to transport layer, we call it segment, and we have demystified this in our last class. When that data gets to network layer, we call it packet. We also demystified this in another class. When that data gets to data link layer, we call it frame. We've also taken care of that in another class. And when that data gets to physical layer, it turns to zeros and ones. It turns to zeros and ones. So this application layer, don't forget, 3 of these layers were bundled together under the TCP/IP model. These were bundled together. So that's why you're not going to hear us talk about presentation layer separately or session layer separately. No, we just dedicated to application layer, even though we're going to say 1 or 2 things about presentation layer or session layer. But your data is still data. And if you remember when we started this class, this OSI model thing, I said application layer is the layer at which you interface with the OSI model. That is where you are. And don't forget, the process on this side is what we call encapsulation. We've taken care of that one before. Encapsulation. This application layer, that is where you interface with the OSI model or with the TCP/IP. So the moment you launch an application, you are doing something, you are at the application layer. Whatever you are doing on your system, that is the application. So the journey always starts from the application layer if we are referring to the sender. Of course, when it gets to the other side, the reverse is the case. It's going to now be from physical layer to data link layer to network layer to transport layer, and that is the order in which they arrange this curriculum. We took your physical layer first, went to data link layer, went to network layer, went to transport layer, and now we are going to be talking about application layer. So it's more or less like they are referring to the receiver end now, which is de-encapsulation. So at the source, we have encapsulation. At the destination, we have de-encapsulation. So you need to understand this. The application layer, that's where you interact or interface with the OSI model. So let's see what we got in this place. You see what they put there? They are all bundled together. Thank you, class 12. Application, presentation, and session layer are all bundled together. Yeah, they're all bundled together. So when I'm talking now, generally, I'll be talking about application layer generally. And I'm going to tell you the most important thing you need to get to know at that layer. So follow me carefully. Application layer. The upper 3 layers of the OSI model: application, presentation, and session define function of the TCP application layer. What do they mean by that? These three layers have been bundled together in TCP/IP model. So in TCP/IP model, you are not going to have anything like presentation layer or session layer. No, we'll only be talking about application layer. So these three layers were bundled together. Don't ever forget that. And look at what I just told you earlier. The application layer provides the interface between the applications used to communicate. Look at that word, interface. Interface. Between the application used to communicate and the underlying network over which the message are transmitted. This is where we are going, guys. Some of the most widely known application layer protocols include, I've mentioned these things before. I say every layer have their own protocols. Every layer have their own protocols. If you remember when I talked about interaction of protocols, I said we're going to come back to OSI model layer, OSI model, and use the layer to explain these things and connect the dots. So it's not enough for you to know about the layers. You must know what the data becomes at each of the layers. And at the same time, you must know what your data are the protocol that operate at each of these layers. You must know the protocol that operate at each of these layers. So you need to take note of that. And that's what I want to talk about in today's class. What happened at the application layers? That's where you interface with the OSI model. And the protocols that operate at the application layer. You need to understand all of these things. Now look at the protocols here. We have HTTP. We've talked about that before when you are browsing. We have FTP when you are downloading. I've talked about that. TFTP also is about download, but when we move things in and out of our router or switches. IMAP when you are receiving mail. IMAP is for receiving mail. I think SFTP is for sending mail. And of course, DNS. And I remember showing you guys about DNS. That is the things that translate our domain name to an IP address. That's the protocol that translate domain name to an IP address. So you need to know all of these things. All of these protocols are called application layer protocols. Application layer protocols. You will remember that I said in one of the classes that some of these things we are learning now, demand will be placed on them down the road. E.g., you don't want people to be able to download on your network, you go and block FTP. Sorry guys, I have smoke, I have cold here. So I'm trying to sneeze, I have to mute myself. I caught cold some days ago. So you block FTP. Why would you want to block FTP? You don't want people to download on your network. And the reason why you want to block that protocol is because you know what that protocol does. You know the job of that protocol. You know what it does. That's why you're blocking it. I hope you're flowing with me. You know what the protocol does. That's why you are blocking that protocol. And you may not want to block the protocol from beginning to the end. Maybe during work hours, for instance, 8 to 12, people are on in the office, 12 to 1, it's break time. You may say, okay, once it's break time, this thing should be available. And you can just do it and your device will take care of that one automatically for you. So this is the point I'm trying to make here. Anything you don't want people to do on your network, or you want to allow or disallow on your network, all you need to know is to go and find the protocol that controls that at the application layer, because that is where the users interact with the OSI model, and block it. You can block the protocol or you can block the port number, and that's why you need to know all of these port numbers. I think we mentioned that in our last class. FTP is 21. HTTP is 80. HTTP is 443. All of those port numbers, we make use of them on the network. Can you people hear me? Thumbs up if you can hear me. Yeah, I think my network just fluctuated now. I just pray we will scale through this to this class with this network. So when you go and get the application layer protocol for that particular activity or whatever, you block it and that's all. Or people are downloading things on your network. Let me say you are hacked and you want to find out what people did on your network. Once you see FTP, you know that this attack is all about download. So all of these protocols, application layer protocol points to what people are doing on your network. And if you happen to see a port number that you don't understand the job of that port number, you can research that port number. And by the time you research the port number, you'll be able to know, oh, this is what the bad guys are using this port for. So don't ever forget that. Don't ever forget that. Now we have some other things to talk about. A presentation. I'm not done. I want to go back to one of the slides where I showed you guys. This is one of my favorite slides that points to this interaction of protocol. I think I really like that slide. I always come back there. Ah, here's the slide. Here's the slide. If you just snap this and meditate on this, digest this, you are good to go with what all of this long story I've been telling you guys for almost 2 weeks now. You are good to go. I can just add some things to it. At the application layer, popular protocols, FTP, HTTP. So I can add HTTPS, SMTP. I can add IMAP, DNS, TFTP. Then I can add Telnet, and I can add SSH. These are popular protocols at the application layers. And what do they do? You need to know what each of these protocols do, what they represent. Non-negotiable for you guys. We're not talking about the ones that are not popular. These are the popular ones. So for a network engineer, you got to know all of these ones here. And I've mentioned most of these ones. Telnet, remote logging, even though you're not supposed to use Telnet. You're working, you want to work, you are in maybe in JAWS or in Nigeria, you want to log into a router remotely, you can use Telnet. You are advised to use SSH. SSH is secure connection. We have TFTP. You want to move things out of the router, especially the operating system, out of the router or into the router. That's the protocol we use. I have demonstrated DNS for you guys. SMTP, I've talked to you guys about SMTP. IMAP also is not about mail. HTTPS, you guys know what it is. HTTP, you know what it is. FTP, you know what it is. There is even one FS something secure. SFTP also. Yeah, secure FTP. It's also an application layer protocol. But all of these protocols cannot stand alone, guys. They have to depend on transport layer protocol. Which of them? Either TCP or UDP. We've taken care of that in the last class. And guess what? This transport layer cannot get the jump all by itself. This transport layer protocols, it has to rely on top of IP, and that is where we're talking about IP address. So these are the things you need to understand. These are the things we call interaction of protocols. Protocols working together to get the job done. So why do you need to know the application layer protocols and the transport layer protocol they work on? When we come to a topic called access list, by the time you want to block a particular application layer protocol, you point to that protocol and you also indicate whether it is running TCP or it's running UDP. So if you don't know, then you cannot create an access list. So you need to know all the application layer protocols, the popular ones, and you need to know whether they run on TCP or they run on UDP. Now, I am not going to expect you to have uploaded everything in your brain right now. No, as we proceed, some of these things, they will stay in your mind or in your brain. That's why you need to keep on reading and read more on these things. So application layer is where you interface with the OSI model or TCP model, and there are protocols that operate at that layer. And these are the popular protocols we're talking about. And this protocol governs some of the things we do, and I've mentioned some of those things. There is nothing you do on your system that there is not an application layer protocol governing it. Nothing. Every single thing you do on that system, every single activity you take, there's a protocol governing that at the application layer. And of course, that protocol will now rely on TCP or UDP. And then, of course, IP is non-negotiable. You shouldn't forget that. So this is one of my favorite. Of course, we need to have our LAN connection, local area network connection, or our wide area network connection. If you don't have LAN in the first place, you cannot send anything. You can't be part of the network. And the most important protocol or technology that we'll talk about is Ethernet. There are others, token ring, every day. I've also taken care of all of those things. So this is what you need to understand. All of this is work together. They work together. And the way they work together is just for us to understand the flow of data. It's for us to understand the flow of data. How data moves from source to destination, encapsulation to encapsulation. I have some things to still demonstrate to you guys. That will be in our next class. Encapsulation, de-encapsulation. But by the time we have driven all these points home, when I start that demonstration, some of these things, that my demonstration will make sense to you. Because I don't have to crack my brain and be referring to something or talking about something afresh. No, I've talked about it already. It's just for now to see some of these things in action. Like IP, Internet Protocol. We learn how to assign IP address to computer. We learn how to use IP address to test for connectivity, and so on and so forth. So we're going to connect all of these dots as we proceed. All right, so let me quickly finish this, guys. I said it's going to be a short journey today. Those application layer. Thank you, Mr. Uche. Thank you, Eric. I think the only confusing layer to some people or some of the activity is the transport layer. When I talked about three-way handshake, that's the one that some people have issues with. But don't let those things confuse you. Okay, guys, we are going to have to say some things about presentation layer. We need to say some things about presentation layer. And don't forget, presentation layer is also embedded in the application layer of the OSI model. There are some things that happens at that layer. So look at what happens at our presentation layer. Formatting or presenting data at the source device into the compatible format for received by the destination device. That happens at presentation layer. Compressing data in a way that can be decompressed by the destination device. That happens at presentation layer. Encrypting data for transmission and decrypting data upon receipt. That happens at transmission layer. Presentation layer. Let me give you a good example. Sometimes you hear people say JPEG. That it has to do with picture. When you want to open picture and all of those things. Some of this kind of anything that has to do with graphics, JPEG, MPEG, all of those things that has to do with display of something, compressing and decompressing, like maybe when you compress data at the source. I'm not talking about the encapsulation that happens under the OSI model. Now you use the software. For instance, you can use WinZip to compress your data, or you use WinRAR to compress data. All of these, JPEG, WinZip, WinRAR, all of those things, they are at the presentation layer. It has to do with presentation issue. And those are the things you are seeing in this place. Anything video, formatting. Look at QuickTime here. People use it to play movie, graphics, JPEG, PNG, portable network graphics. All of those things have to do with you being able to see something and see it correctly and see it in the right format. So the layer that is really, really responsible for you to be able to see and see well with the right format is presentation layer. Take note of that. Formatting, presenting its format, it present the data at the source and make it compatible by the time it gets to destination. You are not going to send a picture from the source and it gets to destination, the picture is upside down. No. Presentation layer will make sure that everything gets to destination the way it was sent from the source. That is the job of presentation layer, guys. It's not doing much. It's not the popular layer because we see say data is data at presentation layer, but the guy is also doing something. It's not dormant there. It's not useless there. It's doing something. That's what we are talking about now. If you are doing encryption like you want to code the data, like, okay, I'm sending $1,000 now. I'm not talking about the process of encapsulation. I want to use a software to do encryption. We use an algorithm, like when we're doing VPN and some other stuff. If I'm doing something like that encryption, by the time I encrypt, that's the presentation layer thing. When it's been decrypted at the destination, that's the presentation layer thing. If you come to cybersecurity, you're going to understand some of this I'm talking about encryption of data. It's like coding your data. We're not talking about the normal process of encapsulation and de-encapsulation. But let's say I have decided to code the data in a way that I use key to lock it. So somebody should grab it along the line. The person cannot decrypt it. The person does not have understanding of what it is. That happens at presentation here as well. Don't ever forget that, guys. Don't ever forget that. Another layer called session layer is not also useless. It's doing something. It creates and maintains, take note, dialogue between source and destination application. It creates and maintains dialogues between the source and destination application. All the layers that you are seeing at the source, they are having continuous conversation with the layers at the destination, front and back, front and back, front and back, front and back. The session layer is the one managing that dialogue. That's why sometimes you hear in the bank, they will say a session was open, but it was not completed. Let me give you a good example of this. If you try to transfer money, the money left your account, it did not enter the account of the person you sent it to. What happened? A session was open between you and the sender and the receiver. But before that session was completed, the session closed. Or before the money was transferred, rather, the session closed and that money got hooked along the line. And sometimes you have to enter bank to tell them that I sent money, the money left, the person didn't get it. They have to now manually sometimes make sure they reverse the money. Unlike this modern day, do I call them banks, OP and the rest of them, they are trying. They make sure that these things are reversed automatically. So it's all about session. So there is no way two people will send money, the sender and the receiver, and there will be a session open between the two accounts. But if that session closes before the money is sent, that's when you see that the money gets hung somewhere. And why would the session close without the money before the money is gone? Sometimes it will be as a result of network. Most of the time, it's always a network issue. So when you hear them talk about, oh, the session closed before the money went to the other person's account, and so the money got in between. And most of the time, it's always with the source, with the sender. But it's not the account, it has left the account, but it didn't get to the other side. And sometimes you will say, go to the other bank, go and complain to them. You left this place, this bank successfully, it did not enter your account on the other side. Why? Because the session closed before the normal time. So session, you need to understand that session and the application of session in our world today. That's what I gave you an example of the banks. So look at it again here. It handles the exchange of information to initiate dialogues, keep them active, and to restart sessions that are disrupted or idle for a long period of time. Session layer does that. End-to-end session, make sure that it monitors end-to-end sessions between the applications. And I've given you a good example when you come to banks. So even though we don't make too much noise about presentation and session layer, that doesn't mean those layers are useless. They are also useful. They have their works, they are what they are doing there. We don't ever forget all of these things have been bundled together into application layer of our TCP/IP. Take note of that. And that's about presentation layer and session layer. So these are the application layer protocols again. I've talked about them before. DNS can run on TCP and UDP. Look at the port number here, port 53. This is another one called DHCP. I forgot DHCP. When you get to an environment, you automatically get an IP address for your computer. This is the protocol behind it. You will use port 68 as a client, and the server uses port 67. And then, of course, you guys know about HTTP, but 80, either of these two ports can be used for HTTP. So we also have HTTPS, which is not mentioned there, Telnet, and the rest of it. All of these are application layer protocols that governs what we do, how we interact with the OSI model. So take note of that. So that's the last thing we want to talk about on the OSI model or TCP/IP model. But then we have some other addition here. When you have peer-to-peer, what comes to your mind? Most of the time, peer-to-peer is just two people talking together directly. This is Roland. This is Wichi. Peer-to-peer. But it doesn't have to be physical, guys. It can be anywhere in the world. There are software now, wicked software that can help you to connect with somebody's computer anywhere in the world, and you are downloading things from that person's computer. For instance, if you have heard about torrents, there are torrent sites or torrent software. What the thing does is, if I'm looking for a particular material now, I will just launch that software. I use Qbuild. It's not good because it can bring in virus into your organization. Qbuild. So what I will do is I will launch it, and then I will search for a particular material, maybe videos or something. Other people that are connected all around the world, if they are also running that software, we are all connected by that software. So if I search, it can take me to somebody's laptop and begin to pull that thing down from the person's laptop. That is a good example of a peer-to-peer. But we can have it in a different version, like when we are connected physically. So I will explain the physical one. And then, of course, I've explained the one that people use all over the world now. It's been a long time that torrent has been there, but it can consume your bandwidth like crazy. So when you talk about peer-to-peer, it's more about two people or two computers talking together. So it can be in this mode. Look at this model here. Client/server mode. When you hear client/server mode, what does that mean? There is a dedicated server somewhere that is serving everybody. We hardly call this one peer-to-peer. But for the purpose of this, in this context now, let's leave it as peer-to-peer. In fact, let me tell you guys. Let me see if it is here first before I talk. Okay. Okay. They call this in peer-to-peer application. Okay, good. 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 So let me finish talking about this. So when you talk about client/server mode, it simply means we have a dedicated server. Meaning it's a server. It's serving everybody. It's serving people all over in that environment. It may be from all over the world or whatever. For instance, www.facebook.com. Facebook is a server. But let me say that website is installing a server and is serving everybody all around the world. And that is what we call client/server mode. Client/server mode. So the client requests for information from the server, and the server dishes out the information out to the client. That is client/server mode. So when you're building a network, most of the networks are always like this. But you can also have networks that are peer-to-peer. This one cannot come under peer-to-peer. You can also have the ones that can be peer-to-peer. Meaning what? You have just two people or more. You can add more people here. There is no dedicated server. In other words, anybody can be a server. Anybody can be a client. That is the best way to explain peer-to-peer connection or peer-to-peer network. Anybody can be a client. Anybody can be a server. What do I mean by that? Let's say this is class rep here. She has some things we are copying from her. I am copying things. Uche is copying things. Pedro is copying things. At that point in time, she is the server because she's the one giving out things. We are getting things from her. Down the road, following day, Pedro can be the one sharing things with us. Class rep is copying things. I am copying things. Uche is copying things. At that point in time, Pedro is the server. The rest of us are the clients. The same thing can happen to Uche. The same thing can happen to me. That is a good example of a peer-to-peer network. Anybody can be server. Anybody can be client. There is no dedicated server when you talk about peer-to-peer network. No dedicated server. That is a dangerous network to run. because you are not going to have order. There's lack of order. There's lack of order. Anybody can be a server. Anybody can be a client. There's no order. That's a peer-to-peer network. That's what I was trying to say. Client to server is not a peer-to-peer network. But then what about the application? That is the application I spoke about earlier. That application connect every user that installed the application together. So if you have any torrent software on your laptop, anytime you launch that machine like this, you have joined that network. Anytime you launch that machine, you power that machine, and that software is running, you have joined that network. How did you join the network? You are using that peer-to-peer application. So it therefore means all over the world, we have built peer-to-peer network. I can be the server, you can be the server, anybody, anywhere, all around the world can be the server. It's because it's not recommended or it's not advised. That's why I want to show you guys here. Because I use it to get some materials. When I'm looking for some materials for my students, maybe I'm doing a training and I need to get them some videos, and I probably want to do some revision. I just go and download the software, go and search for who has this material anywhere in the world. And because we have formed a network, we have formed a connection all over the world, begin to pull those things down from whoever has it. And you know the funniest thing, at this point in time, I may be pulling things down from Uche. When Uche saw down his laptop, if ClassRep has it too, that software will move to ClassRep. I will continue pulling down. The beauty of that thing is if you start downloading, maybe it has gotten to 40%, which is shut down his laptop. ClassRep has the same software. It will continue from where it stops. And then until I get all the softwares completely. That's the beauty of that software. Don't quote me. So look at them here. Common peer-to-peer application. We have BitTorrent, Direct Connect, KeyDonkey, FreeNet. These are different peer-to-peer application of software that people use. And this is dangerous. So what we do in any organization that is sane or is particular about security, we make sure we block anything that has to do with torrents. The torrent is not going to work. But for people that don't know, they don't block torrent. They leave torrent for students, especially in university environment. They will consume your bandwidth completely if you allow them. Students are like vampires when it comes to bandwidth. They drink bandwidth like the way vampires drink blood. Okay, so that is the end of our application layer, guys. I said it's going to be a short class this evening.